Okay, so in terms of the transmission of infection, so we're looking at this idea of this chain of infection. So it's this idea that when you have a pathogen, it kind of follows all these little steps. So you've got an infectious pathogen, um, you have a susceptible host, really, and this pathogen obviously infects this host via this portal of entry. Um, in terms of these reservoirs, it's where the infectious pathogen basically kind of grows and just sits, and it then exits that. It's then transmitted into somebody else. So the reservoir may be another person, really. So the reservoir may be, yeah, another person, and then they're able to exit that individual, and then it's transmitted into somebody else via that portal of entry. Hopefully that's making sense. And then you've got the host who's infected, and now they're creating more pathogens. Um, so hopefully that makes sense. You guys should be really on top of this by now with COVID in terms of ways of controlling transmission, particularly of our communicable diseases. So hand washing, physical distancing, face masks, all the stuff that I'm sure you guys are really, really aware of. So there's a lot of modes of transmission. So respiratory transmission, droplet transmission. Um, Respiratory transmission is basically via the respiratory system. So you kind of hack it out via your respiratory system and then it goes into somebody else's respiratory system. Droplet transmission is kind of similar but a little bit different in that the pathogen can basically travel in the air via droplets. So when you sneeze on something and you then like touch it and then touch your face or whatever, that idea of being transmitted via droplets. Um, Contact transmission, so via direct contact. So for example, the fecal oral route. So yeah, if the pathogen is excreted in the feces and somehow that kind of gets you may not wash your hands properly after going to the bathroom, and then you may touch your mouth, or you may eat something and then that gets in via the oral route. So that idea of fecal oral. Vector transmission, so we talked about malaria at the start, this idea of the pathogen often being like a little parasite in that vector, and then that gets transmitted as well. So if you think about malaria, for example, that idea of avoiding the vector, preventing areas, so like preventing being bitten by a mosquito, getting rid of like mosquito breeding grounds, that sort of thing. And then sexual transmission, so kind of bodily fluids, that sort of thing, pathogens spreading by there, so like your STDs and all that sort of stuff. Okay, so here is a bit of a question. We'll try and read it really fast. So BSE is a prion disease of cattle. So again, how we were talking about how prions often commonly spread from animals to humans. So it's sometimes called mad cow disease, caused by feeding cattle food that contains prions from other infected animals. So you've got prions from other animals, and then you feed that to cows, and then basically like the humans eat the cows. Blah, 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 blah. The time between infection and symptoms appearing can be up to 5 years. So you can have a prion in you, you can eat infected meat, and then 5 years later you get the disease. If you think about it, that's an extremely long incubation period. And you can imagine the kind of trouble with that. There are concerns that VCJD in humans could be caused by eating infected cattle meat. So this is kind of a variant from that. So mad cow disease is in your cattle, like the disease is in the cow, hence mad cow. And then when this kind of spreads to humans, it's your Creutzfeldt-Jakob disease. So yellow fever is a viral disease that affects humans. So here we're talking about something different. So this is a prion, this is a virus. Yellow fever is a viral disease that affects humans. The yellow fever virus can cause symptoms 3 to 6 days after infection. The virus is carried by a mosquito vector. Which combination of approaches would be most effective at controlling the risk of outbreaks of both VCJD and yellow fever? So you can see how there's like so much information, and obviously it's helpful for context. But if you break it down, again, you're not expected to know what VCJD is. You're not expected to know what yellow fever is. Whittle this question down. It's asking, how can we prevent the infection of this prion? How can we affect an infection of a viral disease via a vector? That's the idea. They could have swapped the word VCJD and yellow fever out for anything in the world. Again, you're just having to apply knowledge that you have already. So, prevent all cattle that show symptoms of mad cow disease from reproducing. Remove breeding grounds for mosquitoes. test all cattle for the presence of prions, ensure that all healthcare professionals wear gloves when working with infected patients. In terms of yellow fever, so it's a viral disease that affects humans. Virus is carried by a mosquito vector. So you're going to want to look for something that is particularly targeting mosquitoes. So removing breeding grounds for mosquitoes sounds pretty good. Ensure that all healthcare professionals wear gloves when working with infected patients. Probably not the best thing. Ensure that people take measures to reduce their chances of being bitten by mosquitoes. Yep, that's pretty good. Instruct people who are infected with yellow fever to wear masks in public places. Not the best thing, because this would be effective for maybe respiratory transmission or droplet transmission, but not really for something that's caused by a mosquito. So you're kind of down to A and C. So you've got prevent all cattle that show symptoms of mad cow disease from reproducing, destroy all cattle that have been fed infected food containing the prions. So again, we're thinking of A and D. They could both be quite helpful. So again, what this comes down to is what is the best answer. So if you read, A or C sort of by itself, you may be inclined to choose them, which is important. Oh my gosh, which is why it's therefore important to read all of the answers so that you can get the best option. So prevent all cattle that show symptoms of mad cow disease from reproducing. So that sounds relatively good, but think about the method of transmission. So prions from other infected animals. So basically the cow's got the prion in it, right? And then it becomes VCJD because somebody eats that cow. So if you prevent all cattle that show symptoms of mad cow disease from reproducing, okay, that might be good, but does that stop that cow from having mad cow disease? No. Does that stop that cow from being cut up and then given as food? No. So that's why C is the better option. Destroy all cattle that have been fed infected food containing the prions. Because of that idea that you're preventing at all costs that from becoming meat that someone will eat. Whereas A, prevent all cattle that show symptoms of mad cow disease from reproducing. That cow can still become meat and someone can eat it and they can get BCJD. Hopefully that makes sense.